So last time we learned about Scooby snacks. No, we didn't. We learned about parabolas and quadratics. So let's carry on and help you keep on learning there. Here we go. Okay, so now we're going to go to our next homework. So go to the next page and give it a try. So the half is called the slope. And so the slope is actually going to go, do you remember what it is? What's slope again? Slope is rise over what? Rise over run. So 1 over 2. So we're going to go up 2, or up 1, and then we're going to go over 2. You'll see when we get to it. Let's do the vertex first. Okay, vertex. Vertex. So the vertex is, remember, it's opposite what you think, opposite sign. So, oh, pause me. Did you not try number 9 on your own? You need to try it on your own. I'm waiting. Pause me. Try it on your own. Okay, so we're going to go ahead. Did you try it on your own? Don't stop. Just try. Write something down. Then you can erase it and fix it. It's the only way you're going to learn. Make those neural connections. You need to activate the brain. I want to learn. You learn by trying. So go ahead and try. Okay, so the opposite 4 is -4. Good job. That stays the same. -7. Good. Should we color code it? Let's color code it. So it was a +4 and it became a -4. And the axis of symmetry stays the same. It's still a -4. Good. So we're going to go left 4, down 1, 2, 3, 4, 5, 6, 7. Hey, we just made our axis of symmetry, huh? There's our axis of symmetry. At x equals -4. There's our axis of AOS. Our axis of symmetry. Good. Okay, so now remember what we taught you? Is it upside down? No. Okay, it's going to be weird now because we do have an a value there. And our a value is equal to 1/2. And so that means that we're going to be doing our slope, which is rise over run. So from our vertex now, we're at -4, -7. Instead of going right 1 and up 1, we're actually going to go right 2 and then up 1. Because of the slope, right 2 up 1. That's going to make it go wider. And then left 2 up 1. It's going to make it go wider. What do I know? How do I get the other points? Tricky. You might need an XY table. Oh, I know, right? This one's actually really tricky, is the half. So I'm going to estimate. I could be wrong. Let's try estimating. Okay. So I saw that I plugged in a -2. And -2 with a 4 is +2. +2 squared is 4. And then 4 and 1/2 of that is 2. 2 minus 7 is -5. Ooh. Supposed to be up 1 over 2. So this is the coordinate. Let's see if we did it right. So this is the coordinate -2, -6. Which means right there. Which means when we plug it into our equation, right? We have x plus 4 squared minus 7. Checking with our t-table here. So we plugged in for x, we plugged in a what? We plugged in a -2. So that's 4 with the -2 is a +2. And +2 squared is 4. Good. Then we're going to go ahead and half that. So 1/2 of 4 is 2. And then 2 minus 7, that's supposed to be -5. And I got -6. What did we do wrong? If 1 over 2. Yeah, that's confusing. So let's try looking at our graphing calculator and see. So we're going to go to y equals. We're going to clear that sucker. We're going to go 1 divided by 2. We're going to do open parenthesis. We're going to go and do x plus 4. So x plus 4, close parenthesis. We're going to square it. And then, not -7, but a right arrow. And then subtract 7. So let's just see what the graph tells us. So what does the graph tell us? There's a point at 0, 1. That's pretty. Okay. What else does it tell us? Well, where do we get at -2? Yeah, let's see what negative 2 is. So at negative 2, we get... Oh, it actually is 5. Look at that. Here's something new. Second graph, second table, second graph. And look, here's our coordinates. Here's all our coordinates. Where's our origin? Our origin is at negative 4, negative 7. Okay. So negative 4, negative 7. Another point is negative 2, negative 5. So I got it wrong. Why did I get it wrong? I don't know why. So we're saying it's up 2 over 2? That doesn't make sense. Let's see. So negative 4, negative 7 was here. Negative 4, negative 7. And then I said the slope is making it wider. So I thought it was up 2 over 2. But it's actually over 2. Wow, who knew? Yep, so it's going to be negative 2, negative 5. That was wrong. Okay, so that's going to go ahead and be negative 2, negative 5. There we go, negative 2, negative 5, good. Okay, our other points, if we plug in a 0, we get 1. Okay, let's try it. So if we plug a 0 in, 0 plus 4 is 4. 4 squared is 16. Half of 16 with the half there is 8. And 8 minus 7 is 1. That works. And since it's symmetric, we went 1, 2, 3, 4. Up 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go from the origin. Let's do green origin. From the origin, negative 4, negative 7. We're going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're at 1, aren't we? We're at 1 here, we're at 1 there. So that's a negative 8 1, and this is a 0 1. So those are the coordinates to help you graph it. So there's our graph. So go ahead and connect the dots now. Connect the dots. La 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 la. This teaches me that the slope, right, wider or narrower, is actually different. It's not just the slope, it's more than that. And I'm thinking, I'll have to think about it, but there is a trick to it. Should we take a look? Let's see the trick to it. Let's look at our book. Use your book as a resource. So that's the value here. Okay, and that's flip across the x-axis. That's negative. Oh, it's our a value, right? That's our a value. And so here's our a value. So if our a value, the absolute value of our a value is greater than 1, it stretches it. If it's less than 1, like a fraction, no, then it shrinks it. I'm not sure about that. So stretch it. Yeah, I know if it's greater than 1, it goes narrower, and then if it's less than 1, a fraction, it makes it go wider. But that doesn't really help us that much, does it? Let's see, horizontal stretch or shrink now. Okay, fine. Okay, so then we'll go back here. What's the domain? What's the domain for all these? What's the domain for all these? What's the domain for all these? Negative infinity, positive infinity. Negative infinity, positive infinity. Negative infinity to positive infinity. But what's the range now? What's the range? So remember the range is going to be, remember, put your pencil down. So it's the y value, it's the y value. So at, oops, that's not the vertex. That's not the vertex. What's the vertex? The vertex is negative 4, negative 7. There's a vertex. And so that's how far down we are. We're at negative 7. And we're going upwards to infinity. Now do I need a bracket or a parenthesis? Well, there's a closed hole there at negative 4, negative 7. And so that is our range. That's our range. And we're going upwards. We're going upwards. So it's going to be bracket negative 7 to infinity. Just like that. Okay, there we go. So there's number 9. So check your answer there for number 11. Try it on your own, number 11. Let's actually get to some of these now, because these ones are crazy tricky now. Not too bad once you get the hang of it, actually. So it's just taking a graph. Okay, I'll say you. 11, try it on your own. Pause me. Okay, let's try that one. So that's going to be the vertex is 4, 5. Did you get that right? The axis is x equals 4. Good. So that's over 4 up 5. Good. Negative means to go down, flip it upside down. The negative 2 is tricky now, right? The negative 2 is tricky. So what if we plug in a 5 and a 3 and a 2? See what happens. XY table. So let's say we plug a 2 in there. If we plug a 4 in there, we get 5. But what if we plug a 2 in there? So if we plug a 2 in, we get 2 minus 4 is negative 2. Don't forget, we have to square it. And we also have negative 2 on the outside of that. So negative 2 squared is 4. And then don't forget the negative 2 is 8. Negative 2 times 4 is negative 8. And negative 8 plus 5 is negative 3. So if we plug in a 2, we get negative 3 way down here. Okay, well, what if we plug a 3 in? Well, 3 minus 4 is negative 1. Negative 1 squared is a positive 1. Times the negative 2 is a negative 2. Plus the 5 is a positive 3. So that's right, positive 3. So this one kind of does it. This one kind of does it. What do you mean? Well, let's see. So what was that? That was a negative 2 over 1 for the slope, kind of. Kind of slope. Kind of slope. And so that was down 2 and over. Down 2 and over 1. So we went down 2 over 1, and you can be sure it's symmetric. So we can do down 2, back 1. And then we went all the way down here to 3, so let's make that symmetric. And that's going to be right here. So 6 down to negative 3. Okay, so there's our graph. Now what's the y value there? Because that's the range. What's that y value again? That y value is what? It's a 5. And so we're going from negative infinity to the range all the way up to 5. So the range is negative infinity to 5. Bracket around the 5. And then the domain is negative infinity, positive infinity. Okay, so now what if you have, right? What if you have a coordinate and they give you the shifting stuff and they want you to shift one point and find the new point. Transformation! Kind of weird, but you'll get it. So here's our point, that's our x value. Our x value is negative 4. And our y value is 6, right? So remember that this right here, the plus 6, it's opposite. And so you're going to end up shifting it left 6, because it's opposite. You think right 6 because it's positive 6, but it's actually left 6. And so then we go in and apply that left 6 to our negative 4 now. Okay? So we're going to be left 6 with an already starting point at negative 4. And so that's going to be negative 10 for our new x value, our new shifted x value. Okay? So that's negative 10. So our answer is going to be negative 10 comma something. Now how does the y value work? The y value is pretty easy. The y value just stays the same. If it's a positive 6, it's a positive 6. Okay, so that's this guy. So we're going to take our 8 and take our 6, which is our original, right? Our original coordinate was what? Negative 4. And then what was it? It was positive 6. So now we're going to take our 8. And we're going to go ahead and stack that up there. And so now we're going to go ahead and, should we color code it? Let's color code it. That's too many weird colors. Let's color code it. So this is going to be a 6, which becomes a negative 6. And then this is a positive 8. Let's use a different color for positive 8. And so that's going to add with our coordinate. Okay? And again, what's our coordinate? Our coordinate is negative 4, 6, which goes here, and it goes here. And so when we go ahead and add those, we get 14. So negative 10, 14 is our new coordinate, and that's our answer. That's our answer. So negative 10, 14 is our answer. So you try 14. You try 14. All you're going to do is change the x value. So if it's a negative 4 to begin with, we have negative 4, and we have a 6. Of course, we're going to add. Of course, we're going to add the 5 there, right? We're going to add the 5. And then this is going to change the sign, right? Because that means to change the sign is what that means. So it is going to become, it's just going to multiply. It's actually going to divide, to be honest with you. This means to divide by a negative. And so that'll just become what? That'll become 11. Divide by negative 1 gives a positive 4. Okay, these are weird. That's why I'm doing them with you, because these ones are kind of crazy. But you try 16 on your own. I will give you a hint that you take the x value instead of, it's opposite. Remember x value. Remember for number 16, the x value is opposite what you think, opposite. And so you think divide by 2, but actually you're going to do the opposite. This shows up when you graph this with your calculator. And you're end up being an actually times by 2. A times, you're going to do a times by 2. And then this one will be a times by negative 1/3 to the y value. Okay, give that a... All right, so we are at parent-teacher conference. And got a mistake, a negative positive thing messed up. So 15 is actually like this. So you take our negative 4, 6, and if it's outside, remember if it's outside, then we take that negative 3 that's being timesed, and we multiply it to the y values. So 6 times negative 3 is a negative 18, not a positive 18, a negative 18. And then what about our x value? So it's inside the parentheses, so that means x value. It also means opposite. So x minus 2 is actually going to be right 2, so it's going to be plus 2. And so that gives us a negative 2. So negative 2, negative 18. Way-o! Okay, so those ones are very strange. So finish watching my video for this last one, which is going to be transformation, with our function for every single one. It's going to get crazy. Make sure you watch the video, the next one, because it's crazy. Thanks for watching. You behind the screen. Thanks for watching.